Okay, so what we're going to do right now is we're going to take a look and think about proportional relationships. Now, a lot of you, if you are missing today, we actually just took a look and watched a video about Cake Boss and how he was making a cake for Sesame Street, and he noticed that his characters were actually way too big to fit the size of the cake. And so he talks a lot about having things to scale, which we know what he's talking about, and having things put in proportion. So let's look at this quick little problem here. Hey, have you ever played a video game and found that a day in the game was shorter than a day in real life? Okay, the game designers might have decided that 20 minutes pass in a game for each minute that passes in real time. That would mean that the relationship between real time and game time is proportional. Now, I got to be honest with you guys. My favorite game that I play when I have some down moments is this one right here, Homescapes. Don't know if you guys have ever played it before, but I really like it. And if you, what happens is this game, of course, is not going to load. Come on, load. There we go. When I play this game, if you guys have never played this game, what happens is this, okay? All right, this has, sorry, let me claim my daily prize. This is set up so that it's not time, but it's stars, all right? So basically, it says for however many stars or for however many missions that I complete, it will move on to the next game or next day, and I get to start a new day. All right, so if you think about this problem right here, what we know is during the game, it's 20 minutes for every 1 minute that passes in real life. So what we could do is we could set up a ratio, and the ratio would be like game time in minutes to real time. And again, it's in minutes. And our ratio would be 20 to 1. All right. So basically, when we're thinking about things that are in proportion, the next, if I actually had 2 minutes, if I did 2 minutes in real time, that would mean my game actually covers 40 minutes. Okay. If I had 5 minutes, if I played 5 minutes in real time, that would end up being like 100 minutes in game time. Now, we know that these are in proportion because they are all equal to each other. And all of them have the same unit rate. And the same unit rate, define the unit rate as we divide. 20 divided by 1 is 20. 40 divided by 2 is 20. 100 divided by 5 is 20. Okay, they all have the same unit rate. Well, I'm going to actually teach you a new word for unit rate. So the unit rate that we know, remember the unit rate is a comparison of two quantities by division of 1, right? That's what a unit rate is. And we know that our scale, right, is a unit rate. Here's the new word that you guys are going to learn to use. It's also called the constant of proportionality. The constant of proportionality. So that is our new word that you're going to hear me say a lot of. And basically, it means the unit rate or the scale. Okay, constant of proportionality. Okay. All right, so let's talk more about proportion. Okay, in 1 week, each cat at a shelter eats 7 cans of food. The ratio of cans to cat food. That is very, very, very important. Okay, how this is written, and we talked about this a little bit yesterday. How this is written is how you need to look at it. So it says cans is first. So the first number in your ratio goes to cans. The second number is cat food, and that goes with that number. So basically, if I were to write this out, 7/1, the 7 represents the cans, and the 1 represents the cat, the cat food. All right. Okay, so that is how we're looking at this. Now, the number of cans of cat food in the shelter needs depends on the number of cats that it has. Show how many cans are needed for different numbers of cats. Now, I'm going to tell you guys this right now. Okay, a lot of you guys are going to look at this table and you are going to say, oh, hold on, let me make this table really quick. So you're going to, so here's our cats and this is our cans, right? And so 1, 7, 2, 3, okay, 28, 35. I'm going to stop there. You guys will probably look at this and you'll be like, oh, this goes up by 1 every single time. Okay, so it's +1, +1, +1. So this must go up by 7 every single time. Okay, +7, +7, +7, which is true. However, when we are talking about proportional relationships, I want you guys to start thinking about the relationship not this way or this way, but the relationship between these two. So basically, the number of cats to get to the number of cans is times 7. That's the relationship between the cats and the cans of cat food. So if we keep going, 2 times 7 is 14. 3 times 7 is 21. Uh-oh, now we know the cans, so if we have to work backwards, we're not going to be timesing by 7. We're going to do the inverse, which is dividing by 7. So that's 4. Oh, we know the number of cans, so we're going to divide it by 7, and we get 5. Up, we have the number of cats, so 6 times 7 is 42. 7 times 7 is 49. Up, this we're going the opposite direction, so we're going to divide by 7 and we get 8. Now, I realize you guys are looking at this and you're like, Mrs. Parkin, I just went up by 7s every single time and it was fine, and I went by 1s every single time. But I want us to start getting into the habit of looking at the relationship between the two quantities. All right, not the relationship between the cats, okay, or the cans of food, but the relationship between the two different quantities that we're looking at. Okay, now, B, are all of the ratios in the table equivalent? Explain. Well, let's just do a couple of them. All right, and let's do cans to cat food. Let's just do that, right? So if you think about it, we have 7/1, and then we have 14/2. We have 21/3, 28/4, and so on and so on and so on. If I were to divide every single one of these, they all come out to be 7. So yes, they are equivalent because they, when divided, they all equal 7/1. Okay, all right. C, what is the unit rate for cans of cat food per cat? So do you guys see how this is written? How this is written is how you write it. We want cans to cats. So I know that there's 7 cans for 1 cat. And that is our unit rate. Because remember, unit rates have to have a denominator of 1. So our answer is 7 cans per 1 cat. And I know they tell us that information up here. But no matter which one of these we use, okay, if we use 56 to 8, all we would do to find the unit rate is we would divide. So 56 divided by 8, 7/1. Okay, so that's how you find the unit rate. So now D, suppose you know how many cats are at the shelter in any week. How could you find the number of cans of cat food X cats will eat? Okay, so the problem says this, okay, cans, we're looking for how many cans if we have X, all right, and that's like an unknown, it's our variable number of cats, okay? Well, what we already figured out is that each 1 cat eats 7 cans of cat food. So basically, we could write out an expression. Cans equal, right? Okay, we don't know how many cats we have, but we know that they eat 7 per week. So it's 7x. So 7 times the number of cats equals how many total cans we will need. Because watch, if I have 4 cats, 7 times 4, I'm going to need 28 cans. If I have, if I had 8 cats, 8 times 7 per week is 56. So this is an expression right here. Or you could have just said times the number of cats and 7, okay, in words. All right, so hopefully you guys understood what I just said. Okay, so Ramona makes catnip for toys for the cats at the shelter. She puts the same amount of catnip in each toy. Ramona makes 4 toys with 12 grams of catnip. Complete the equivalent ratio table to show how many toys Ramona can make with different amounts of catnip. Okay, so what we know is this, that if she doesn't need any toys, she needs no grams of catnip, all right? And what we know is if she wants to make 4 toys, that she needs 12 grams of catnip. This was the only thing that we knew, all right? That's the only piece of given information. So remember when I talked to you guys about knowing the relationship between these instead of what goes on from here to here to here? This is a prime example. So basically, you're going to ask yourself this. What do I do to 4 to get 12? Well, we multiply it by 3. Interesting. So maybe our unit rate, oh, and I bet you that comes down here a little bit, you know, will be, it's 12 grams per 4 toys. And if I reduce that down, okay, all right, that's interesting. So with that being said, I could probably fill out this one and this one. So 2 times 3 is 6. So if I make 2 toys, I need 6 grams because here's the scoop. All right, 12 over 4 equals 6 over 2. Okay, because they both reduce down to 3. All right, how about down here? I'm going to multiply by 3, so that becomes 15. Okay, and so that must mean that 15 over 5 also is equivalent to those two. They're all in proportion. Now, we come across these right here. Since we know that the relationship is times 3, if we know the grams of catnip, then if we go backwards, we're not going to times 3, we're going to have to divide by that unit rate. So 3 divided by 3 is 1. 9 divided by 3 is 3. So there is our table. Okay, there's our table. Now B, describe the relationship between the number of grams of catnip and the number of toys. So describe the relationship between the number of grams of catnip and the number of toys. And basically, what we know, every single one of these, and if I keep going, 3 over 1, 9 over 3, okay? Basically, we can say for every 3 grams of catnip, you can make 1 toy. All right, so that makes sense. C, what is the unit rate for grams of catnip per toy? Guess what? We already figured that out. Okay, 3 to 1. That's our unit rate. How can Ramona find the number of grams of catnip she needs to make a certain number of toys? So basically, for this problem right here, all we're going to do is she could multiply, the number of toys by 3. All right, because look, if we go back up to this table, 5 times 3 is 15. If I want to make 10 toys, 10 times 3 is 30. I need 30 grams of catnip. Okay, so now it says write an equation to show the number of grams of catnip, G, number of grams of catnip, G, Ramona will make to make T toys. So this goes back to this problem right here, right? The number of cans, look at this, this is an equation. So the number of cans equals 7 times the number of cats. So in a roundabout way, that's an equation. So what we know is the grams equal 3 times the toys, right? Well, we know the grams of catnip is G, and we know the toys is going to be represented with a T. And congratulations, you guys. We just wrote an equation that shows proportional relationship. That's so cool. Okay, number 3, the table shows the hours needed for different numbers of people to clean up after school dance. Is there a proportional relationship between the 2 quantities? So here's what we know. We know if we have 2 people cleaning up, it takes 12 hours to clean. 3 people is 9, 4 is 8, and 6 is 6. So to find the proportional relationship, we're going to write these out as a ratio, all right? And I'm going to do hours. Typically, you want to do this one first because, and that's a whole nother story. It talks about independent variables to people, all right? So here we go. The first one would be 12 over 2. The next one is 9 over 3, 8 over 4, and 6 over 6. Now, to figure out if there is a proportional relationship, all of these have to have the same unit rate or the constant of proportionality. So 12 divided by 2 is 6. 9 divided by 3 is up, right there, I can stop. 6 does not equal 3. So these are not in proportion. And 8 divided by 4 is 2. 6 divided by 6 is 1. Okay, so these are not, this table does not show a proportional relationship. Okay, all right. Okay, so with that being said, okay, what I want you guys to skip to, here is your homework assignment for tonight. Yeah, oh yeah, oh yeah. Okay, your homework assignment, it's pretty simple. Okay, you guys are doing page 52. numbers 3 and 4. So you only have 2 problems that you have to do tonight. But obviously there's a lot involved in each one of them. So you're definitely going to want to take your time as you go through this. Okay. So